This is a surface area mensuration type chapter. This is not the analytical geometry circle. That we will do along with triangles. Okay. So chapter name is area related to circle. So let's start with some basics related to circle. Absolutely from basic. Suppose you have never studied a circle. So we start from there. Okay. What is a circle? A circle is a collection of points which are not that chapter. This is area related to circle. A circle is a collection of points which are equidistant from a given point, and the given point is known as center. So we generally say circle is a circle. Okay. So we say circle is a set of points. Right? Equidistant from a given point. These all we will not say when we study circle chapter again in an analytical geometry. Equidistant from a given point, and the given point is known as the center of the circle. Now when you go to higher classes, so what we will do, we will change this word set of points. A set of points which obeys any condition. What is the condition here? The condition is that these points are equidistant from a given point, right? Set of points can also have some other condition, like a set of point which is equidistant from a line. So set of points which obey any rule is called locus of locus. Locus is collection of points which actually obeys, and in 11 you will be hearing this word. Locus is set of points which obey any given condition. Locus is plural, so loci will be known as the, sorry, locus is singular, loci will be the plural. Focus, foci. ठीक है, ये knowledge के लिए equidistant from a given point. इसका मतलब है that by now we know that there is a given point O, and this given point, all the other points, this circumference is actually a collection of all these points, right? And these locus of points actually form what is known as the circumference of the circle. These all you know, nothing new. Circumference of the circle, right? Now the line that joins the point, the center, to any point on the circumference is known as the radius of the circle. So this is the distance of each point from the center of the circle. And that's why we say that this distance is always fixed in a circle, and this is called the radius. No confusion on that, right? So itna bhi aap samajh gaye hain. Now second aspect. Now since you have known a circle, our next point is, going with higher classes, we are also supposed to see a circle with a bit of rotation that helps us to identify major arc and minor arc. So we always put an arrow. You can put it in any direction, but follow the nomenclature of that direction, right? Why do we put it? There's a reason. Say suppose I take a circle out here with center O, and I'm saying the circle is rotating in this manner, clockwise, right? It's your way of understanding. आप अगर इसमें, if you put anti-clockwise, heavens don't fall, you're still correct. And let's pick 2 points. Let's pick 2 points out here. And let's say this point is A and this point is B, okay? So line joining any 2 points on the circumference is called a chord. Line joining any 2 points on the circumference is called a chord. So AB is a chord. Clear? Since AB is a chord, we go to grade 9. There are some theorems. Equal chords subtend equal angles at the center. Equal chords are equidistant from the center, and line joining the center and perpendicular to a chord bisects the chord. Okay, these 3 you should know. Now, what do you mean by subtends an angle? Subtends an angles means if I am the chord will just do one namaskar at the center. So chord subtends an angle means this is the angle. Clear? Are you clear with what do you understand by subtends an angle? So we say that the chord is subtending. AB is a chord which subtends an angle theta at the center. Clear? Fine. Further. Now again, circle. Now whenever we have a chord, a chord divides a circle into 2 segments. This is a segment, this is a segment. This segment will be known as minor segment. Minor segment. And this will be known as my major segment. So far clear? What all did you learn? Circumference, definition of circle, center, radius, circumference, then chord. Then you also learned angle subtended by a chord, and chord of a circle divides the circle into two segments, one called the major and one called the minor. Up till here, okay? No issues? Chaliye, aage. Okay. And the longest chord of a circle is its diameter, which will pass through the center. And then the 2 points on the circumference are called diametrically opposite points. What are they called? Diametrically opposite points. What I am trying to say, suppose you have a chord which passes through the center, right? And then you create 2 points out here, P and Q. P and Q will be called as your diametrically opposite points. Okay? So by now we know segments, chord. Chale aage. Okay. Next. Know the 3 theorems of chord. Equal chords are equidistant from the center. Equal chords subtend equal angles at the center, and line from the center of a chord which is perpendicular to the chord bisects the chord. Okay? Chaliye. Next. Now here we will see there will be use of those theorems which will be in circle chapter. Namaskar, trouser and samosa. Okay, all those 3 theorems. Again, another circle which is having a rotation in this side, say this is my the rotation that I have given to my circle, and I pick up 2 points on my circle, say this is a point and this is a point, and I name these points as A and B. Now this AB will be known as an arc of a circle. A broken portion of your bangle is the arc of a circle, right? And the arc of a circle is such that now we will see the rotation. If you see the rotation, then if you are going from A to B, you are actually at the smaller portion of the broken circle. So AB will be known as my minor arc. Minor and major we can specify only when we give direction to the circle. And then you are so you may say, sir, why will I not name it as BA? No. Go by the rotation. Rotation is this way. You cannot go against the rotation. As per your rotation, naming can be either AB or it can be BA. BA will be major arc, AB will be minor arc. So I hope by now you understand what is a major arc and what is a minor arc. Is this clear? Okay. Now then comes the word angle subtended by an arc at the center of a circle. Angle subtended by an arc. Now this is the arc. The arc will say namaskar. हुजूर माफ कर दीजिए at the center. So हुजूर माफ. Clear हो गया? Now this is arc angle subtended by minor arc AB. Minor arc AB is subtending an angle how much? Theta. Therefore major arc BA is subtending what angle? Angles are always measured anti-clockwise. So this would be your other angle. So this will be 360 degree minus theta. This is major arc BA. And that angle will be reflex. Okay, na? However, if you take diameter, that is exactly half of the circle as your arc, then you don't have any major or minor arc. You have what is called a semi-arc. At that time, the angle subtended on both sides will be 180, 180. Okay? Ab kuch aur. Grade 9. Still we are in grade 9. Okay. Now let's see. These are theorems which you will be using left, right, center in the circle chapter. So if you are not clear, get it cleared now. We will not study them again. This is AB. Rotation of circle is in this manner. In this manner. That means this AB is the minor arc. Right? Angle subtended by an arc at the center is twice the angle subtended by the arc at any point on the remaining part of the circle. That means if I put any other angle, and if this angle is theta, this is 2 theta. Angle subtended by an arc at the center is twice the angle subtended by the same arc at any portion on the remaining part of the circle, which means that it could have been here also. It could have been here also. Same. This also will be theta. Right? So sir, can we have some more angles? As many as you wish, as long as it is in the other portion. This also will be theta. Okay. From here you can pull out one more corollary, and the corollary is something like this. Angles on the same segment of a circle are equal. Now look, this is stylish. Now take this and this as the 2 points. This is A and this is B, and say this is the rotation. Now I won't be actually drawing. I won't be drawing the arc. I would be actually looking at it from the perspective of a segment. Now this is a segment. Now we say angles on the same segment of a circle. This is what is called the trouser theorem. Angles on the same segment of a circle are equal. Means this angle, if it is theta, this angle will also be theta. Angles on the same segment of a circle are equal. Understood? Now you saw this theorem from the perspective of minor arc. Let's see this theorem also from the perspective of major arc. Right? Let's see this from the perspective of major arc. So let this be my circle now, and circle is rotating in this direction. Similarly, this is my point A and point B, and let me now I am concentrating on arc BA. Okay, now I am concentrating on arc BA, which is my major arc. Now what does BA subtends at the center. This is the angle that BA is subtending at the center. This angle should be twice the angle subtended by BA on any of the remaining portion. Now the remaining portion is the small portion. So on small portion, whatever angle you will subtend, let's say this is the angle. If this angle is theta, then this is 2 theta. If this is theta, then this is 2 theta. This is more for circles chapter. You won't use it here. Based on this, we can have one more corollary, theorem, and that is like this. One more corollary theorem, and that is, say suppose neither I have a minor arc nor a major arc, and I have a semi arc. I have a semi arc. Now in this case, just look, what is the angle subtended by the arc at the center? It is 180 degree. That means at any other portion, it should subtend half of 180. 90. So this should be 90. This theorem is called angle in a semicircle is a right angle. Angle in a semicircle is a right angle. This is also known as my samosa theorem. Samosa, namaskar, and trouser. Bas. Chalo. Ye sab we'll be using in next chapter, so no more revising again. Now coming back to our arcs. Our arcs will do some very interesting formation. Let's go back to our arc. So this is a circle. Now I take an arc out here. This is arc AB. Rotation of the circle is in this manner. So minor arc AB. The minor arc AB, whenever it is subtending an angle at the center, it creates a portion of a pizza, and this portion is known as the sector. This is known as sector. Now since this is small portion, this will be known as minor sector, and the remaining part will be known as major sector. Have you understood? Okay. Now let's say this arc is subtending an angle theta. From here your chapter starts. This arc is subtending an angle theta. Have you understood? Okay. If theta was 90 degree and if the circle was a margarita pizza, this is a margarita pizza, and theta is how much? 90 degree, and you take out this portion, how much of a pizza did you eat? यार डम्बोस जैसे आंसर करते हो. If this is a margarita pizza and if this angle is 90, you ate quarter of a pizza. Simple. 1/4. 360 degree minus there, 1/4 of a pizza. If the angle is 180, then how much are you eating? Half of a pizza. अभी सब बोल पाओगे. एक बोल दिया ना, अभी सब बोल लो. This is quarter of a pizza. Do you agree? Now just see. What is the, let's say the radius of this circle is r. What is the area of the circle? Pi times r square. Do you agree? Right? Now we need to find out the area of the sector. Formula wise it's very easy, but let's understand. When you ate this much portion with this as 90, how much did you eat? 1/4 of the area. 1/4 of the area. Now let us put a analogy. From here to here, how much is it? 360 degree. 360 degree. You ate how much? 90 degree. You ate 90 degree out of 360 degree, which is basically the 1/4. So your area of the pizza that you ate, hey, what happened? If you are having common cold, please stay at home. This is virus spreading week. I've just recovered from all sort of donated illness by my favorite children. My immunity is losing nowadays, and plus others. They can always attend from home, right? There's nothing to be feeling bad about it. सबको बीमार करके ना, I love you, I want to sneeze on you. ऐसा करके थोड़ी कोई बात है, घर में बैठो, ठीक है? So 1/4. So how much did you eat? 1/4 pi r square. Now suppose I don't know the angle out here, then this area will be how much? It will be theta portion of 360 degree into pi r square. By the same analogy, if the quarter of a pizza is 90 by 360 of the pizza, then this much is how much? Theta by 360. समझ में आया? नहीं आया? बोलो. आया तो? Therefore, this is what is known as area of a sector. Area of a sector is given by pi r square theta by 360 degree. How the formula came? I just tried to explain you. Hope you have understood. एक बार फिर से, बेटा जब आप क्वार्टर ऑफ ए पिज्जा खाते हो, एंगल कितना होता है? 90. आप उसको क्या बोलते हो? 1/4. You ate 90 degree out of 360. The entire is how much? 360. Out of that, how much? Where did you cut your pizza? After swiveling 90 degrees, you cut your pizza. So you ate 90 degree out of 360. That corresponds to 1/4. Here we don't know what is the angle. So how much are you eating? Theta portion of 360. Full marks is 360. This is like pie charts which you did. Full marks is how much? 360. How much are you eating? This you did in pie charts. Theta portion of 360. So pi r square theta by 360. Clear? Great. Now let us see one more analogy to it. Another circle, right? Now we will make it a little bit complicated. Let's bring a chord and let's bring the radius. Fine. Now O A B. In this OAB, this much is the area of this segment. Now somebody tells you find area of minor segment. Find area of minor segment. Agreed? Area of minor segment will be area of sector minus area of triangle OAB. Do you agree or not? Area of sector. Sector means the portion of the pizza minus the area of the triangle will give you the area of the segment. And here is where all your problems will be. Finding an area of a sector is very easy if this particular angle is given, right? The whole issue comes with area of triangle, right? Now let's see what all things to do in this area of triangle. In such a formation, this triangle will always be isosceles. Always, because these two are radius, right? ये याद रखने का, because you may try anything. That means if this angle is beta, this angle will always be beta. Agreed? Now area of a triangle, what are formulas do we know? Half base into altitude, right? Your luck will be very good if the altitude is specified to you. Say suppose this is the altitude and let's say this is M. So if OM is given to you, you can just do half AB into OM. Any child will do that. That is one way of finding the area of the triangle. Another way of finding the area of the triangle is using Heron's formula. Two radiuses are known to you, and if the base chord is known to you, you can find it. समझ में आया? Another would be, if since this bisects the chord, you know this and you know this, by Pythagoras theorem you can find out OM, and still you can find out the area. But sometimes what they may do, they may juggle around with the, what you call, the data that is given to you. Now say suppose, since this is an isosceles triangle, in an isosceles triangle always remember the altitude is also the perpendicular bisector and also the median, and also the angle bisector for the vertex angle. So sometimes they may say this angle is 120. So each of these angles become how much? 60, 60, right? And you should remember one chapter which is called trigonometry. If you use trigonometry in this, look at the right angle triangle OMA. Okay, look at OMA. This is OMA. My whole interest is to find out the value of OM. Either OM or AM. Sometimes chord length might be hid from you. Chord length is hid from you. But they have given me the radius. They have given me this angle. Suppose they say this angle is 120. For example, this angle is 120 means each angle is 60. So 120 means rest of the two must be contributing to the balance. How much is the balance? 100. If this is 120, then 120, 180 is 60. So these two should be 30, 30 each. Have you understood? So we have got the value of beta. Beta is 30. So we can always use, and we know the value of this particular radius. Our job is to find the chord length. If you use the relation cos beta is adjacent side, which is AM, divided by how much? R. And AM is half of your chord, right? So look at here. AM now becomes R cos beta. R is known to me, and what do you call? Cos beta is also known to me, right? I now want to find the base of the triangle. The base of the triangle is 2AM, which is equal to 2R cos beta. No issues. ये मिल गया हमको. And then you need the altitude. Once you have found out AM and you know R, so you know the altitude also. What will be the altitude? OM. OM will be equal to root under R square minus AM square, which is 2R cos beta whole square. See, this formula may be there in many of the sample books and children get very confused. Nothing to get confused. You just use your common sense. Do you know the value of AM? AM's value is equal to R cos beta. 1 minute, children. AM's value is equal to R cos beta. Pay attention. What should be the value of OM? OM should be hypotenuse square minus AM square. Hypotenuse is how much? R square. Minus AM square. AM is how much? R cos beta square. So now you know the value of OM. You also know the value of AB. Can you now find the area of the triangle? Area of the triangle is half AB into OM. Anything difficult? Not at all. But in your book, this will be written as a formula, and children do Rattu, and after doing Rattu, they become Totu. Cos beta root under R square minus R cos beta whole square. Please don't memorize this formula. If you memorize, you will always make a mistake. You try to understand. You want me to do again? I can do again. All we are trying to do here is to play a relation between this angle, this side and this side. एक बार और करें, ठीक है? एक बार और करते हैं. आ जाओ. Let's do it once more and let's see whether we have understood or not. My job is to find out the area of the triangle. That is the trickiest part in this problem. How to find out the area of the triangle. Let's take a bigger circle. Fine. And pay attention. So we have something like this, and this, right? they have specified the value of this particular angle. They have specified the value of this angle. Based on this, what I have done a construction in which I have put a line from the center which is perpendicular to the chord. And as per grade 9, this will bisect the chord. Yes or no? This is A, this is B, and this is O. This is the radius of the circle R. This is the radius of the circle R. If I want to find out the area triangle OAB, area of triangle OAB, I would say that the area is half times AB times OM. Let me put this as M. Do you agree or not? No issues still here. So your job will be, they will not give you this, they will not give you this. They have mentioned this angle. Whatever is this angle, 180 minus this angle is equal to this plus this. This is isosceles, and this is an isosceles triangle also. That means this side and this side are equal. Right? Based on that calculation, let us say that this angle came out as alpha. समझ में आ रहा है कि नहीं? Every one of you understood? Let's say they said that this angle is 120. If this is 120, then this is 30, 150, another 30. So alpha is 50. समझ में आया? You will be given this particular angle. This angle is, let's say, theta. So you know 180 minus theta is always equal to 2 alpha. Clear? Since we have got alpha, now we start, our job is to find AB and this. So first what we do, we take cos of alpha in any one of the triangle. Cos alpha is what? Adjacent by hypotenuse. So can I write this as half AB divided by R? Did you understand this or not? Half AB divided by R. This can be written as AB by 2R. एम नहीं लिखा ना, एम बाद में, तो ए बी चाहिए ना हमको, फॉर्मूला में ए बी चाहिए, हाफ ए बी डिवाइडेड बाय आर, राइट? सो फ्रॉम हियर कैन यू फाइंड आउट द वैल्यू ऑफ ए बी? ए बी इज इक्वल टू 2r cos alpha. Established? You got AB? Very good. Now we also need the value of OM. Now how to look at OM? Achha, we can write OM should be equal to root R square minus AM square. Can I write this? Which should be equal to root R square minus half AB square. Yes. Half AB square. ठीक है? और OM is equal to root R square minus, what is AB? Half AB is straight away, you don't need AB. Half AB is R cos alpha. Half AB is R cos alpha. So we can write R cos alpha whole square. ठीक है? To make it more stylish, I can make it R square 1 minus cos square alpha. Can I do it? No issues? Take the R square out, so it comes out as R root under 1 minus cos square alpha, which is nothing but R sin alpha. 1 minus cos square theta is sin square theta, root of sin square theta is sin theta. अब मजा लो यार मैथमेटिक्स का, क्या छोटा छोटा लेंथ इनटू ब्रेथ करता रहेगा क्या? बोलती बंद. MTB बोलती बंद is brought to you by all. मेंटोस हो गया क्या? समझ में आ रहा है कि नहीं? This is the value of what? OM. बस batter ready, paneer ready. Paneer ready, batter ready. Now we can make paneer batter fry. चलो बनाते हैं. area is equal to half. What is beta AB? AB is 2r cos alpha. 2r cos alpha. Agreed? Okay. And what is OM? R sin alpha. R sin alpha. This is the area. This portion, if you are not understanding, is AB, and this is AB, and this is OM. Now at grade 10 and at your level of छोटा सा, नन्हा सा, प्यारा सा CBSE का दुलारा बच्चा, only this much is sufficient. But we can also get it into a little bit more stylish. We can make it stylish. देखो कैसे होगा? Now see, area is what beta? Area is a 2D entity. Therefore, radius. See, you have to get a meter square. Radius. It's 2D. Our formula is correct. But if you go to higher classes, this will just change a bit. And the change I am writing here, the change is area will be equal to half r square 2 half r square 2 sin alpha cos alpha. Can I write this? Half r square 2 sin alpha cos alpha. And in grade 11, this is a formula. This formula is half r square sin 2 alpha. Half r square sin 2 alpha. This is, I mean, if you are going sin 2 theta is equal to 2 sin theta cos theta. ये grade 11 stuff है, huh? This is grade 11. So at your level, this much is sufficient for you to find the answer. Did you understand? And now look here, you can go even further mathematics. Look here. What is 2 alpha? 2 alpha is 180 minus theta. 2 alpha is 180 minus theta. So formula becomes so small. 2 alpha should be 180 minus theta. Yes. Has the snake सूंघ गया क्या? चुप हो गए सब लोग. इतना जान के रखो, इसको याद मत करो. You will goof up this formula if you memorize it. Don't memorize. You just find out the area of a triangle by the simple bacha process. Half base into altitude. My job is to find out base. My job is to find out altitude. For that, I will be using trigonometry, in which I will bifurcate one portion. One side I will take out by trigonometry. The other side I will take out in the method of Pythagoras theorem. Bas, job done. Samjha? Chord length will be given to you, or angle will be given to you. So this is how you find out area. This is the most complicated problem that you can have, where they will give you what do you call do we have that problem? There was one that 3 girls keep cycling. That is in grade 9, I think. Fatima, Mohini, and what keeps cycling? What is the angle between them? No, it's in circles chapter. Chhod do, not here. That's in grade 9, not here. चलें, लाइए एक आध problem करके देखते हैं. Let's see. We don't have anything more than this. Area related to circle. Oh, only one exercise. Very easy. But this will also be very calculation intensive, huh? So let's do this horse wala problem. This is one of my favorite problems. Shall we? So our problem is somewhat like this. There's a plot. A horse is tied to a peg at one corner of a square-shaped grass field. So this is a square-shaped grass field. Very good. So grass is growing here. A lot of grass. Grass. Right. And we have tied a horse with a peg at one corner. the peg at one corner, and each side of this field is how much, beta? 15 meters. 15 meters is the side, and you have tied a horse. So please understand, when you tie a horse to a peg, you are supposed to consider whether when the horse stretches the what you call string, that will basically become like this. This is the stretch string of the horse. And once they say it's asking you by means of a 5-meter long rope. So this rope is how much? 5-meter long rope. Okay, this is a 5-meter long rope, and here we basically have whatever our horse, though it is not looking like a horse, but please understand this is a horse. Okay. So this is our horse who is tied to it. Now the horse will be actually moving in what way? It will be sweeping circle. Do you understand? We are very much aware with this diagram. You know why? Because in our childhood, when we used to make mistakes, means mischief, so thrashing was very common in the house. So all moms used to have one cane stick. See, this problem I have sensed in my whole life. Let us see that demo first. The moms will have a cane stick with which they will hit you. The best way to escape is what? When you are a kiddo in grade 1 or 2, get under the bed. Beds did not have box type bed. Now just see. Now what has happened? Now you have gone and you are hiding under the bed like this. Your mom can't get into the bed, na? She's an adult. So my mother will do what? She will put the stick inside, and then she will swivel it this way or the other way. Are you understanding? So basically my mother will be sweeping an area like this. What is the safest point to hide? Here. Probability of the stick hitting you is minimum. So कितना दिमाग हम लोग लगाते थे. Probability of you getting hit is minimum. Have you understood? She has put the stick inside and now she is doing this so that तुमको लगे. And from here you actually give 2-3 cries. और नहीं करूँगा. That will satisfy your ego that he got hit. Otherwise she'll keep on doing this. Na? There has to be an escape also. So this horse problem is also like that. The horse is actually tied and the horse will be sweeping a sector. They are asking you, find out the area that this horse can actually graze upon. How will you approach? Is this logic समझ में आया? So it says a horse is tied to a peg a horse is tied to a peg at one corner of a square shaped grass field of size 15 meter by a 5-meter long rope. Find the area of the part of the field in which the horse can graze. The horse cannot go this part, right? Horse can graze here. Can you find out this area? You know the radius of the circle. Are you bhutanikas? This is a part of a circle only, na? And don't you think the horse is grazing on a sector? Angle is how much? 90 degree. So the horse can graze on how much portion? Grazing area. Grazing area. The grazing area will be given by pi, then 5 square, r square, r square, theta divided by 360 degree. Theta will be 90 degree. It's a square. Then they are asking you the increase in grazing area if the rope were 10 meter long instead of 5 meter long. ये भी कर लोगे? ठीक है. Very good. Can you all attempt question number 11 from NCERT? Car wiper. Have you seen car wipers? Car wipers will also sweep sectors. Right. Try to do question number 11 from NCERT and give me some relaxation.